Okay, so this video is going to be looking at lesson 10, which is representing characters. So to start with, you are going to have a go at doing the Do It Now task. 4 questions. It's all based on work that we've done previously, so you can go back to your previous lessons and have a look to try and find the answers to that if you don't know them off the top of your head. Then for task 1, it's a sort of a cryptic code that you need to decipher. So we've given you this information here and we've given you this message to decode. Write your answer down here. Now I'm going to leave that up to you to try and figure out how to do it. For task 2 then, what you're going to do is you're going to use the table above, assuming that you've completed this table, to then write your own name in binary. So, you know, for example, if your name was Cat, then what we could do is we could look up here and say, this is the binary number for K, this is the binary number for A, and etc. Okay, and then you're going to write that as a binary number in this table here. So a bit of a bonus there if your name is quite a short one. So, on to task 3 then. You're then going to make notes on how computers represent characters. So I'm just going to flick to a PowerPoint at this stage. So when we're talking about characters in a computer system, we're talking about any letters, so uppercase letters, lowercase letters, A to Z, etc. It could be a digit. Sorry, I was going to double click on it to highlight it. It could be a digit, so a 0 or a 7 or a 9, etc. It could be a space, so if you press the space bar on the keyboard, it could be a punctuation mark, full stop, etc. or various other symbols, /, @ symbol, hash, etc. So when characters are stored on a computer system, they need to be stored as binary numbers. Remember, everything in a computer system is actually stored as ones and zeros. So for example, this binary number here, I don't know why there's a 2 on the end, I'm pretty sure that should be a 1, that represents a lowercase a, and also this 10 here should be a subscript. It should be a tiny little number 10 to tell us that it's actually the number 97, and that's what that 2 is. Sorry, that should be a tiny 2 down here. Let's see if I can change that live on screen. How unprofessional is that, especially if I can't do it, which I can't. Superscript, is that at the top or the bottom? Typical, wrong one. Let's change that again to subscript. Okay, so that's what it should look like. It should have a little 2 there. Kind of format painter it. There we go. So this is what it should look like. So okay, so this binary number here, we know it's binary because of the tiny little number 2, is 97, which represents an A, etc, etc. So that is how characters are stored in a computer system. Now, the reason why we have standard character sets, like that one that you just saw, where certain numbers represent certain letters, is so that different computer systems can communicate. So if you send some what you think is text over, but of course it's ones and zeros, if it then gets to another computer and they're using a different character set, those ones and zeros will mean that all your words are jumbled up because they're using different characters. So we tend to have standard character sets. Now you don't need to remember the exact codes for each one. You don't need to remember that Z is whatever binary number. Okay, so you don't need to remember that. You just need to know what they are. So, as I said, why do we have them? Standardized character sets allow for data interchange between different programs or computers, like I just said. Now, the one that you've just seen is called Ascii. Stands for, it's a 7-bit code. It stands for American Standard Code for Information Interchange, as it says, the one that you saw earlier. The problem with this is that you're only able to represent 128 different characters, and computer systems need a lot more than that. Especially if you're taking into account other languages, so including spaces, /s, all the letters, all the uppercase letters, lowercase letters. 128 isn't enough. It was extended to allow it to use 8 bits, which meant that you could use 256 characters. However, you know, if you think about French and Spanish languages, when you've got all the accents above the letters and Chinese symbols and things like that, there just wasn't enough available characters. So another character set was invented, which is called Unicode. It's a standard character set that's sort of replaced many others, It was originally an extension to Ascii, and it uses 16-bit storage. So how many do you think? So for the other one was 8 bits, and we could store 256 characters. Have a think about what you think 16-bit storage might be. Now, a lot of you perhaps said 512. Actually, it's 65,536 characters, because it's 2 to the power of 16, which is an incredible amount of characters, obviously, so it's plenty for all of our needs. So what you're then going to do at this point is I want you to go back to your OneNote, and I want you to have a go at completing task 3 and task 4. You can then have a go at the extension task. Obviously it won't be for one of your classmates, but you could just write a secret code there in binary, and then you can have a go at this summary task down here. So that's the first part of the lesson done. There will be a follow-up part in a moment explaining lesson 11 and 12, but at this point, if you could just have a go at doing this page on your OneNote, and then go back to Teams to have a look for the second part of this lesson.